Alright, hi guys. Okay, just to do a quick recap from our previous video, we actually talked about internal energy of substances. Okay, so in internal energy, you can actually have internal kinetic energy and internal potential energy. Okay, the internal kinetic energy has to do with the motion of particles from kinetic level, from a microscopic level, and that you can see from the temperature. Okay, what about internal potential energy? From a microscopic level, it has to do with the forces between the particles, and that is basically related to its state change. Okay, so this is what we covered previously, but let's do a quick experiment to actually show you what this is. Okay, basically, just to show, I've got a beaker here full of ice, but this ice is actually below freezing. It's about at about minus 34.6. I've got a data logger um, in the ice. Okay, and what do we have here? What can we see from this video that was shown is that as time increases, you see what actually happens, because when the beaker is actually being heated on a plate. Okay, check out what happens to the ice. Okay, so you can, the ice actually gets heated up, and there's a gradual increase in the gradient. So in other words, the temperature of the ice will get heated up, but once you start seeing water and ice together, oh, that's basically the start of the melting process. And you can see it's actually a flat line graph. So only when all the ice has actually melted, the temperature will then start to go up again, all the way until it starts to boil. That means it starts to change state again. You can see liquid and gas, so it actually goes back into a flat line. So every time you see a flat horizontal line, what's actually happening is that the of the liquid or of the substance is actually changing. Okay, so this is just a direct application you can see from our previous video. Okay, so just to make a quick screen grab, so just did a quick screen grab of the video, and you can see in the first screen grab at the start, actually a change in temperature as seen from the gradient of the heating curve, and there's only one state. Basically, it's ice only, right? So as long as you're heating ice, what's happening is that the temperature of the ice actually starts to increase, and that's it. Now it's still in one state. That means we still are not. The ice is still not changing any state yet. Okay. Okay, so after some time, when you hit the first horizontal line, the first flat line, what's happening? This flat line means no change in the temperature. Okay, so this is a temperature scale 0 degrees Celsius for ice. So when there's no change in the temperature, okay, you can see that there are actually two states inside. You can see what are the two states? Ice on top here and water. So there will be ice and water together, and this process is actually called melting. Right, so after it actually has fully melted, when you see uh, the substance has become total liquid or total water, there will actually be a change in temperature, because as you constantly heat it up again, what happens? Okay, the liquid actually increases the temperature, and as you can see, once temperature starts to increase, there will only one state existing, that is in this case liquid. Okay, and over here, finally, when you hit the flat line again, it means it's changing state again. So once it changes state, it means there is no change in temperature, but only the change in state. That means from liquid into gas. So you can see over here, the two states are actually liquid and gas. Okay, you can see bubbles here forming, right? Okay, so basically, in a nutshell, okay, our heating curve, you can see as you heat it up, what happens is that it starts off from a solid, then when it melts, it's a mixture of solids and liquids, then becomes liquids, and then liquids and gas at boiling, and once they have finished boiling, everything has turned to steam, right? So basically, the flat lines here, the first flat line over here will be melting, and the second flat line here will be boiling. Okay, so you can see there are two main types of lines here. The parts of the graph will be when temperature is increasing. As temperature is increasing, you can see these slopes here, whether it be solid, liquid, or gas. The kinetic energy is increasing. Okay, what does that mean? Basically, it means that The molecules are either moving faster over here, either vibrating faster here, moving faster here, flying past each other faster, and there is also a temperature increase. Okay, and what about the flat lines? Flat lines simply means potential energy is increasing. Okay, so that means as you add heat, because throughout this entire heating curve, I'm always still adding heat, right? Okay, so where does the heat go? At the start, it either goes to kinetic energy, then or potential energy. So in this case, what does it mean by increasing the potential energy? Simply means at these stages, okay, the bonds are actually being weakened and there is a state change. And as you can see, temperature is constant. Okay, so like what we know, so just to elaborate a little bit more about bonds weakening, you can tell from solid to liquid. Liquid has got weaker bonds and gas has got the weakest bonds. So that's why you need an increase in potential energy to actually see that weakening of bonds. Okay, so for cooling curve is basically the opposite. Okay, as you cool a substance down from gas to liquid to solid, you can see in between condensation, these two flat lines will be condensation, and the opposite of melting will be freezing. That's right. So you can see the slopes will represent kinetic energies again. So decrease in kinetic energy because why? The temperature is decreasing as well as the particles are moving slower. Okay. So what about these horizontal flat lines? So the flat lines is potential energy decreasing and they are used basically to form stronger bonds and there will be state change as you can see here. You're right, temperature is constant. So hope you found this video useful. Okay, I'll see you guys in the next.